So this is the Unit 2 Section 2 video, and today we're going to go over reflections and translations. So our objective is identifying and drawing reflections and performing translations, and we're also going to use a vector to translate shapes today. So isometry is a transformation that does not change the shape or size of a figure. Reflections, translations, and rotations are all isometries. Isometries are also called congruence transformations or rigid motion. So when you guys are looking at the EOC or at a county DA, an isometry basically means that the size doesn't change. It's the same shape. And that happens when we do reflections, translations, and rotations. Some other ways that might be expressed is by congruence transformations or rigid motions. You guys should recall that a transformation moves a figure, the preimage, by flipping it across a line. The reflected figure is called the image. A reflection is an isometry, so the image is always congruent to the preimage. When we talk about reflections, we're going to reflect them across a line, and that's called the line of reflection. And then that line of reflection becomes a perpendicular bisector to every segment that joins each point in its image. And you're going to see how that works as we work through the lesson today. In addition, a translation is a transformation along a vector such that each segment joining a point in its image has the same length as the vector and is parallel to the vector. We're going to talk about that one too as we move through the lesson. So this first example says, tell whether each transformation appears to be a reflection and explain. So referring back to what I just talked about, we're going to draw a line from each of these points. So we're going to draw a line from each vertex here, these three at least. Then we're going to draw what we think is a line of reflection. Notice here that it does bisect this piece up here and it bisects there, but it doesn't bisect our third piece because this part right here is longer than the part on the left. So this is not a reflection because we don't have a perpendicular bisector for every line that connects the vertices. So this is a no. The image does not appear to be flipped. Now this one over here, our B, again, we're going to draw some lines here. And then we're going to draw, again, what we think is that line of reflection. And again, these are all perpendicular. And notice this time they do bisect. Well, if I'd drawn it perfectly straight, they would bisect, but you guys understand what I'm saying. So that line of reflection bisects all of those lines that connect my vertices of that shape. So this one is a reflection because it looks like it's flipped across the line. So go ahead and do these two and then come back to me when you're done. All right, so this first one is kind of different looking, but I don't know if y'all noticed, but this is a longer side, and it doesn't look like, I can't even really tell where the other longer side is, but let's just go ahead and do this. So if we look at these points here, and we draw down through the middle here, or what we think is the middle of one or the other, it's not the middle of both. So we, again, know this one is not a reflection. And then this one over here, again, if we draw our lines from vertices and we draw a line between those two, that again is a perpendicular bisector. Perpendicular means that it's at a right angle from those lines, and bisector means these two resulting segments are congruent. So that does tell us, yes, the image appears to be flipped across the line. So we're going to draw a segment from each vertex of the preimage to the corresponding vertex of the image, and your construction should show that the line of reflection is a perpendicular bisector of every segment, connecting a point to its image. A reflection is a transformation across a line, called the line of reflection. Show that the line of reflection is perpendicular bisector of each segment, joining each point in its image. So notice we got A over here, and we've got A prime over here, and that would go on so forth with all the other points, B, B prime, C, C prime, D, D prime, and all the points that are in a particular image. All right, so now we're going to talk about some rules here. So we're going to talk about reflection rules. So if we're reflecting across the x-axis, notice here, if we reflect across the x-axis, this is our x-axis here, then we're going to change our y value. So down here at the bottom, if we're reflecting across the x-axis, we are going to leave our x what it is, and we're going to change our y. Down here at the bottom where it says change, we're going to say we're going to change the y's sign. The next one is reflecting across the y-axis. So the next one is a reflection across the y-axis. And again, here's our y-axis. And what's going to change then is obviously our x. So we're going to go negative x comma y. And again, what are we going to change? We're going to change our x's sign. That's what we're going to change. Last one is across the line y is equal to x. Now I want to talk to y'all about this. So if I had the point 2, 3, and the x became the y and the y became the x, that would then be 3, 2. So what did I really do? I flipped my letters so that y is x and x is y. So that's what I want you guys to write. So change x to y and y to x. That's what you're going to do here. Okay, these are our rules. Now we're going to apply them. It says reflect the figure with the given vertices across the given line. So what I want to do first is plot those 3 points. Once you've done that, you can pause the video, do that, come back to me. Then we're going to write the rule. And we're reflecting across the x-axis, so we're going to write the rule that xy, and we're going to always put that arrow there, xy becomes x negative y. Remember, if we're reflecting across the x-axis, it's the y that changes, and we're reflecting across the y-axis, the x changes. So now we're going to apply this rule. So that basically means we're leaving all our x values here the same, but we're going to change the sign of all our y values. So that would make this 2, positive 1, negative 4, positive 3, 3, negative 2. And then we're going to plot those points. And when we plot those points, you should see that these are the reflections, and we're also going to designate them with our prime. So we're going to have x prime, y prime, z prime. And again, we reflected this across the x-axis, this axis right here. So you should be able to see that this is one away up here and this is one away down there. This one is 2 away from the x-axis there. This is 2 away down there. And again, over here, 1, 2, 3, 1, 2, 3. Hopefully you guys can see that. All right, so our next one, again, we're going to plot the points. This time we're reflecting over the y-axis. So our rule is going to be xy becomes negative x comma y. So this time we're going to change the signs of all of our x coordinates. So the negative 8 becomes a positive 8, the negative 3 becomes a positive 3, the 3 becomes a negative 3. Again, we're going to plot those points, and this time we reflect it across the the y-axis. There's our y-axis. And notice here again we can count. So our original was 1, 2, 3 away from there. So our new is 1, 2, 3 away from there. Over here, our original was 1, 2, 3 away. So over here again, 1, 2, 3 away. And up here, 1, 2, 3, 4, 5, 6, 7, 8 away. So we can do that same thing here. 3, 4, 5, 6, 7, 8 away. So that's another way for us to look at these reflections. How far away are they from that axis of, or our line of reflection? Here's our third one, reflecting across the line y is equal to x. Again, we're going to plot our points R, S, and T, and we're going to write our rule. Our rule is xy becomes yx. So this time, all we're going to do is flip these. So for R up here, we're going to do 2, negative 2. For S, we're going to do 0, 5. For T, we're going to do negative 1, 3. So those are going to be our R prime, S prime, T prime. Then once again, we're going to plot those. We're going to plot those. And I want to show you guys that this now is our line of reflection. Now this one's a little different than the other one because we got to count over from this line. So here, our original point up here, R, was, if we go from this line here, we can go from this point 1, 2, 3, and 1 up. So that means down here, from that same point right here, we're going to go 1, 2, 3, and over. So that's how we can do that with our line of reflection when it's y is equal to x. So go ahead and do these 3 and then we'll go over them. So here again, our rule, we're going to plot our 3 points and then we're going to write our rule. xy is it becomes x negative y. Just going to change the signs of all our y's. Once again, going to plot our points, and you should see that it was below the x-axis, and since the x-axis is our reflection line, then we're going to go above that when we were below it before. This one, plot the points. And then, yeah, I didn't plot the points first, but here's our rule. Again, we're reflecting over the y-axis. So we're going to change x, change all the values of x. That'll become positive 2, negative 5, and negative 5. Our y's stay the same. So once again, plot the original. There it is. And plot our transformed or reflected. And again, you should notice this is our line of reflection, right? So this was one away, 2 away to the left, this is 2 away to the right, so on and so forth from that line of reflection. Our third one is, again, the same shape, RST. We did this 3 times. Now this one's y is equal to x, so this time we're going to flip them. We're going to put the y where the x is and the x where the y is. So that means this very first point isn't going to change at all because it is on the line y is equal to x. And that's one of the things you should notice is when, actually, let me go back to this one before. This one, yeah, let me go back to here. This one. Notice that s did not change. S did not change because it was on the line of reflection. Just like the one we're about to do, this negative 2 is not going to change either because it's on our line of reflection because x is equal to y. So here again, we're going to plot those points and you will see, again, this is our line of reflection here. And each of those points are the same distance. You talk up and over, down and over, okay? So this one, now we're going to talk about translations. So we want to see if this first one, letter A, is a transformation. Now I talked to y'all earlier about this, so we're going to go ahead and connect these. We're just going to do these 3 and draw our line. Now that looks like that's a perpendicular bisector. So meaning that's congruent to that, that's congruent to that, that's congruent to that. So this would be a reflection, not a translation. So this is the answer to this question is no, because it's asking us if it's a translation. It does appear to be flipped. Now let's talk about this one over here. So now we're going to draw some lines here again from these vertices from one to the other, and they should be straight lines, even though mine don't look that straight. Now notice, what you should notice now is that all 4 of those lines are the same length. So that's what I'm going to do first. I'm going to put some tick marks on these to show that they're all the same length. The other thing that you should notice about these 4 lines is that they are all parallel. And that's what indicates to me that this is a translation. When all those lines from those vertices to their corresponding vertices on the transformed image, when those lines are parallel and they're congruent, then I know that this is a translation. Okay, so let's do this one, and then you guys put me on pause, come back, and we'll discuss it. Okay, so here again, I'm just going to draw a couple of these. I'm going to draw this one, and I'm going to draw this one. Notice again, what do you notice immediately about these? They are the same length, and they are parallel. So once again, we can say that these images have been transformed. The one over on the right, I don't even think those are the same shape. So we're going to say no on this one. Not all of the points have moved the same distance. And again, we could try to draw a line there, but it doesn't even look to me like they're the same shape. So that would not be a translation because translations are the same shape. Recall that a vector in the coordinate plane can be written as, notice these brackets are really pointy. We got A here in the position of our x value and B in the position of our y value. So this right here is going to be a change in x, and this is going to be a change in y. Okay, So what does that mean? That means if I'm talking about a change in x, I'm talking about things moving left or right. And when I'm talking about a change in y, I'm talking about things moving up or down. Okay? So that's what we're about to talk about. So we're going to pull those values from the vector and we're going to use them to talk about what kind of change happens in a diagram. So on this one, if you notice on this first one, we have a value for x, but we don't have a value for y. So in the vector, this would look like this, a comma 0. So that means our x value is going to change by a, but our y value is not changing at all. And so that means it's just going to move left or right by the value of a. On the next one, again, we have a 0 in for the x, and we have b in for y. This is what the vector would look like. So once again, our x value, we didn't move left or right at all. We just moved up or down. Now the third one is the vector would look like this, a comma b. And on this one, we moved left or right by the value of a, and we moved up or down by the value of b. Okay, so now it says translate the triangle with the vertices D, E, and F along the vector 3, -1. So we're going to write a rule again. So we're going to say xy is, and we're going to add the 3 because that's a positive 3 there to the x, and then we're going to subtract the 1 from the y value because it's a -1. So we're going to do that to every one of these. So basically we're going to add 3 to the -3 here. We're going to subtract 1 from the -1. That's what we did there. That gives us 0, -2. With our next value, we're going to add 3, subtract 1, so we get 8, -4. Add 3, subtract 1, so we get 1, -3. So those are our 3 points. And then if we plot both of them, again, you should see that these things move. Now let's talk about how much this moves. So this 3 right here means that it moved 3 to the right. 3 units, right? And then that 1 means it moved 1 unit down. So if it was a -3, it would have moved to the left. If it was a +1, it would have moved up. Now let's count that and see if we can see what we're talking about. So 3 units to the right. So let's just take one of these points. Let's take D. So this is our original image, the blue one. So we got 1, 2, 3, and then we've got 1 down. So that's exactly what it did. And that happens with all these points. So if we do F, 1, 2, 3, and 1 down, okay? And if we do E, 1, 2, 3, and 1 down. So that's how our points translate. So this next one, I'm going to go ahead and draw it for you first because I want to point some things out to you. So let's draw our original image. So that would be S, 0, -7, right there. That's our S. Then we've got T, -4, 4, up here. Then we have U, -5, 2. Then we have V, 8, 1. So there's our V. So I'm going to go ahead and connect these now. And normally when we get stuff like this, they're going to be in consecutive order, but this one is not. So here again, now we're going to talk about what does this statement right here mean. It means that we're going to go 4 units left, and we're going to go 5 units up. So I want you guys to watch as I do this now. I'm going to actually transform each of the points this time. It's a great way to check your problems after you've done it mathematically or even before, and then do the math to check that. So we're going to start with this point U right here. So with this U, we're going to go 4 units left, 1, 2, 3, 4, and then 1, 2, 3, 4, 5 units up. So that's our new U. So that's U prime right there. Going to do it with T as well. 1, 2, 3, 4, 1, 2, 3, 4, 5. There's our new T, T prime. Going to do it with the S. 1, 2, 3, 4, 1, 2, 3, 4, 5. And we're going to do it with the U, the V. 1, 2, 3, 4, 1, 2, 3, 4, 5. So that's our new shape. So we're going to go ahead and again connect our dots here with this shape. And you should see that this shape shifted 4 to the left and 5 up. Now what are we going to do here? We're going to write our rule. That's our rule. Again, remember that we are we're subtracting 4 from the x and we're adding 5. So all of these numbers, that's what we're going to do. Going to subtract 4 from the 0 and add 5 to the -7. Going to subtract 4 from -4. We're going to add 5 to the 4. We're going to subtract 4 from the -5. Going to add 5 to the 2. We're going to subtract 4 from the 8, and we're going to add 5 to the 1. So these points, if you go back and look at them, they are the points that we have drawn by doing it point by point. So here's our final problem. Translate the quadrilateral with the vertices 2, 5, 0, 2, and 1, -1, and 3, 1 along the vector -3, -3. So again, let's talk about what this -3, -3 means. So it means we're moving 3 to the left and 3 down. So we could plot our points first, or we can actually write our statement and then do the math. So we're going to subtract 3 from both our x value and our y value this time. And again, this is our rule. And I'm pretty sure I told my students that you should write the rule, use the rule, and then plot the points. That's the process you should use. Write the rule, use the rule, and plot the points. So here we go, subtracting 3 from everything. When we do that and we plot both images, this is what we get. And again, we could count 3 to the left and 3 down for every one of these points. So we're going from the blue to the red. So we could count 3 to the left and 3 down for every point, and we would find our new image.